In 1974, a radical new theory emerged. In the early solar system, there were dozens of mini-planets chaotically orbiting the sun. According to the theory, one of these was on a collision course with Earth. The idea was the brainchild of Bill Hartmann, who was trying to explain the origin not of the Earth, but of the Moon.
What we came up with was that maybe during that period of intense impacts, maybe very large impact hit the Earth and blew some crustal outer mantle rock off of the Earth into space around the Earth, and the Moon formed from that material.
Hartmann suggested that another planet, about the size of Mars, crashed into the Earth. He claimed that the Moon could have been formed by debris from that collision. To many scientists, this was nothing but fantasy, but Hartmann had evidence. Collected from the Moon itself.
I fall in the plum crater getting this rock.
Footage from the Apollo 16 mission in April 1972 shows astronaut Charles Duke struggling to pick up a large sample of moon rock to bring back to Earth for geologists to analyze.
That's 20 pounds of rock.
At the Johnson Space Center in Houston, this actual piece of moon rock is still kept under strict laboratory conditions.
I would say, behold the Moon. This is an actual piece of the Moon, and it's the largest single rock that they brought back from the surface of the Moon when the Apollo astronauts went there. We can't touch it. They don't want human beings touching these rocks and leaving organic material on them.
Until the late 1960s, geologists thought that the Moon formed in the same way as the Earth, by clumps of mineral grains sticking together in the solar dust cloud. They believed it had layers, like the Earth, and a heavy iron core. But when geologists analyzed lunar samples, they were astonished to discover that the moon rocks contained much less iron than they expected.
One of the mysteries has always been, why isn't there as much iron in the Moon as there is on the Earth if the two objects are right close together in space?
The question bothered Hartmann so much that he began to think that conventional theories about how the Moon formed might be wrong.
That lack of iron in the Moon, or to put it another way, the fact that the Moon is made out of rock that looks like the crust and the upper mantle material of the Earth, that was a clue that the Moon may have formed from rocks from the outer portion of the Earth.
This was the key to Hartmann's idea of a collision between Earth and another planet. The force of the impact completely destroyed the other planet and flung billions of tons of Earth's crust and mantle out into space and into orbit around the Earth. Within a few thousand years, this debris clumped together to form the Moon. Advanced computer models showed that the collision was a glancing blow. The other planet did not hit Earth head-on. This meant that while Earth's outer layers were ripped off, none of its iron core was blasted away.
That lack of iron would end up explaining why we have a Moon that is only the rocky material without the iron material.
Hartmann's collision idea is now accepted as fact. It was his fascination with the Moon that led to a new understanding about a vital stage in the formation of the Earth.
The Moon always, to me, is a reminder that we live in a larger environment than just the Earth. It's the cosmic environment. The inner solar system is our environment that we can move around in now.